Hello, everyone. Good morning, afternoon, or evening. Dear authors and welcome guests, welcome to Technical Session 9B. My name is Alesha Muller, and this session will be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic, it is my great pleasure to welcome you to the 11th International Conference on Information and Communication Technology for Sustainable Development, ICT4SD 2026 in Goa, India. The 11th edition of the conference is being organized in a hybrid mode. The physical event was held yesterday in Goa, and the virtual event is being held from 9th to 11th July 2026 via Zoom. I hope you will enjoy the knowledgeable and interactive sessions throughout the day. In this session, we will have 10 presentations. Each presenter will be given 10 minutes for the presentations and 2 minutes for question and answer. On the 9-minute mark, I will raise a gentle reminder. There is another request to all the participants. Please stay connected with us till the closing remarks. If you have any query or update, then you can write it to me in the chat box. Before we start the session, I would like to introduce you all to the chair for today's session. Dr. Nidhi Tiwari is an associate professor at Department of Electronics and Communication Engineering, IET, Sage University, Indore, India. With 13 years of experience, her expertise spans VLSI design, intrusion detection and prevention, computer networks, network security, cybersecurity, data science, artificial intelligence, and machine learning. Dr. Nidhi is dedicated to advancing research and education in these cutting-edge fields. Welcome, ma'am. I request you to please say a few words.
Hello, am I audible, ma'am? Hello, ma'am, am I audible?
Yes, you are.
Okay. So, hello everyone. It is my great pleasure to welcome you all to this session at 11th International Conference on ICT for Sustainable Development. As the session chair, I am honored to be part of this esteemed gathering of researchers, professionals, and thought leaders from around the world. This conference serves as a vital platform for exchanging ideas, discussing research, and fostering collaborations that can drive innovation in our particular fields. The session ahead promises to be both insightful and inspiring, with distinguished speakers who will share their expertise and latest findings. So, before we begin, I would like to extend my gratitude to the organizers, sponsors, and everyone involved in making this conference a success. I encourage everyone to participate actively, ask questions, share thoughts, and take full advantage of this opportunity to learn from one another. With that, let us begin. Thank you, and let's have a great session.
Thank you, ma'am. Now, let's start with the presentations. Our first presenter for today is Dhaduk Jeet, who will be presenting a comprehensive review on automated packet-level forensics for detecting port scanning in campus networks. You may now begin.
Yes. Good afternoon, everyone. I am Dhaduk Jeet, and I will today present my project work titled as Comprehensive Review on Automated Packet-Level Forensics in the Campus Environments. So I will now share the screen. Wait a minute, just. Yes. So let us begin. So introduction is the port scanning. As nowadays we know that port scanning is one of the most common reconnaissance techniques used before cyber attacks. And attackers use port scans to identify open ports, active services, and potential vulnerabilities before launching an attack on any systems. But detecting port scans in campus network is challenging because there is legitimate administrative scans. Students are doing laboratory activities, dynamic, and the environment is dynamic. And traditional IDS solutions often generate high false positives rate in such environments. So the objectives for our research is to review the recent research on packet level forensic techniques for port scan detections. So basically, I focused on the span of 2020 to 2025 for my research, and The second objective is to analyze major detection approaches, which are rule-based, statistical, and machine learning-based. So rule-based is basically the fingerprints or the known patterns, which is we can like if or then situations. Like if it is the attack like is this, then it will be this attack. Then statistical. So statistical is like basically mathematical, which detects ratios of synchronous and reset packages or technology bits and fan outs in the system. And machine learning based, we use algorithms which are trained on large data sets, which analyzes the complex patterns. The third objective is compare modern IDS engines and data sets. Next is identifying existing research gaps in campus environments. So the final objective is propose a campus-oriented detection architecture based on current research findings. Literature survey was like the IDS survey shows it highlights the scalability, but the disadvantages is false positive is a great major challenge. Machine learning and transfer learning for IDS, it improves the detection accuracy, but depends on dataset quality. And port scanning detection study says accuracy is reported high, but limited in real world validations. NABI trap framework. So it emphasizes deployment and post deployment evaluations. And the ABPF and or XDP research enables low latency packet processing and detections. So overall observation on research survey was detection accuracy has improved significantly. Real world deployment, false positive reductions, and campus specific evaluation remain open challenges. This brings us to the problem statement. There are these major challenges in campus network, which I observed was high false positive rates, dataset limitations, real-time evaluations, explainability issues, and resource constraints. The methodology I used was research approach was conducted a comprehensive review of packet level forensics techniques for port scan detections. Focused on studies published between 2020 and 2025, as I mentioned earlier. The literature review research on IDS port scan detection, MLTL approaches, and network forensics. Examined recent dataset tools and deployment strategies. And comparative analysis was like classified approach into rule-based, statistical, and ML hybrid. Research outcome was identified key research gaps and deployment challenges and proposed a campus-oriented detection architecture. So the detection approaches and results were like I said, the three main. Rule-based was the strength. It was like we can find low false positive for known attacks only, like limited against new attacks or attacks which are modified or some altered like. And the statistical, it is explainable and lightweight, but requires a careful tuning. ML or hybrid. So detects complex patterns as we discussed earlier, ML machine learning to train larger data set, newer data set, which helps us to detect complex patterns. But it also depends on data set qualities. The key finding here was hybrid approach provides the best here, so accuracy and scalability and practical deployment for campus environments. The proposed campus-oriented architecture, which I found was like first campus traffic, then is entered to a pre-filter like ABP of XDP, so that traffic which is binning can be filtered out before to sending it to needs engine, so which can be effective and not be overhead or overheating not done. Then ML analysis layer, then SIEM or SOC dashboard. This will benefit like low latency packet filtering, context of detection, reduced processing overhead, and better scalability for campus deployments. The conclusion in future scope is like the port scanning remains a major reconnaissance threat in today's still existing IDS solutions struggle in busy campus environments. High false positive rates remain a significant challenges again, and hybrid detection architectures offer the most practical solutions. And the future scope is streaming and online machine learning, expandable AI for IDS, privacy over network monitoring, development and realistic campus dataset, real-time deployment studies. So overall conclusion is the hybrid approach combining rule-based statistical and machine learning techniques appears more suitable for campus network environments. Hello.
Dr. Tawari, do you have any questions? All right. In case there's no questions, we'll move on to the next presentation. Our
Okay.
next presenter for today is Kabir Shah, who will be presenting a temperature-activated floating agitation system for mosquito breeding control. You may now begin.
Yes. Thank you. Good evening. My name is Kabir Shah. I'm going to be presenting a presentation on my paper, A Temperature Activated Floating Agitation System for Mosquito Breeding and Control. This project is about a chemical-free mechanical way to stop mosquitoes from breeding in stagnant water. It's thermally activated, so that it switches on only when the temperature conditions favor mosquito breeding.
Excuse me, Kabir, you're not sharing your screen.
Oh, one second. Yeah, is my screen visible now?
Yes, it is.
Okay, yeah. Yeah. So, as I said, this product is about a chemical-free mechanical way to stop mosquitoes from breeding in stagnant water, and is thermally activated. So the global problem. So, why this matters is because globally, mosquito-borne diseases cause over 1 billion vector-borne cases and more than 1 million deaths every single year, and nearly 40% of the world's population is at risk. And the root cause is almost always the same. It's due to calm, stagnant water, because even a centimeter of calm stagnant water is enough for a female mosquito to lay eggs and for breeding to occur. And critically, larval survivals peaks sharply between 25 and 30 degrees Celsius, and outside this window, the breeding largely collapses. And so that temperature window is the key design constraint for my device. Um, yeah. So, looking at the existing control methods, chemical insecticides work, but they cause toxicity and resistance. Biological control is sustainable, but it's slow and habitat specific. And genetic methods are promising, but they're very costly and heavily regulated. And simply draining the water is labor intensive, impractical for permanent water bodies, and it can also be a cause for water loss. So what I found through my literature review is a clear gap. So researchers have shown that mosquito development is tightly gated by temperature, yet there are no mechanical agitation systems that couple the activation um, that couple the activation of the device to the thermal window. And most of them just run continuously, which wastes a lot of energy. And that's the gap this project addresses. So the design, so it's a small buoyant 3D printed housing that floats on water, that floats on the water surface, and it's built following Archimedes principles. So it has a design constraint that the submerged depth must stay under 60% of the housing height, so it never takes in or on water. Inside, there's a 60 RPM DC motor which drives a vertical shaft into a bevel gear assembly, which converts a vertical rotation into a horizontal output. The output then spins a partially submerged three-blade propeller, which generates radial surface waves. It's a simple drive train with a low part count and easy to maintain in the field. Um, on the physics side, for wave characteristics, I use a linear finite depth gravity wave theory. At our forcing frequency of 1 Hertz and a water depth of 0.2 meters, the dispersion relation gives a theoretical wavelength of approximately 1.55 meters, but the estimated Reynolds number is around 10 to the fourth power, which indicates turbulent flow, meaning that the surface disturbance we that is observed is a combination of gravity wave progression and near field turbulent mixing from the propeller rather than a clean wave, which is why it's so effective at disrupting breeding. Additionally, there's a temperature sensor that reads the water temperature every 2 seconds, and there's an ESP32 microcontroller which only switches the motor on between 25 and 30 degrees Celsius. And outside that window, the it draws zero power, and this gives us a 98.8% control accuracy. Um, this was tested. To test this, I use a tank with a constant 0.2 meter water depth and regulated mixer taps, ramping the water up from 20 up to 32 degrees Celsius. For each run, I measure the temperatures. I measure the motor's on and off state and the radial extent of surface agitation over 60 seconds and the power draw, while also checking for any structural issues. Um, uh, this is a short video on the prototype in action. Yeah. So moving forward, for the first results slide, as you can see, the motor stays off below 25 degrees and switches on precisely at 25, plus with a uncertainty of 0.3 degrees Celsius. And similarly, it activates or deactivates as it goes past 30 degrees Celsius with a uncertainty of 0.3 degrees Celsius. This gives us again a control accuracy of 98.8% with the relative deviation of only about 1.2%. So the activation has been shown to be precise and repeatable across every trial. Um, the agitation itself, so over 60 seconds of continuous operation, the mean agitation radius was 0.18 meters with only with only 0.03 meters of variation across all trials. However, it must be considered that the radius was lower than estimated by the theoretical calculations because the tank we used was confined and not endless. Additionally, power consumption averaged at 0.74 watts across the entire activation range, which is low enough to run comfortably and which allows for a future scope of making this machine solar assisted. And across all our repeated trials, we saw 100% surface coverage and 100% structural integrity. This means that there were no leaks, no vibration issues, no mechanical failures across all trials. So comparing it with the existing methods, um, it's clear that chemical control is toxic and breeze resistant. Water removal wastes water and needs constant labor. Biological methods need ongoing maintenance, and our system, in contrast, is fully automated, needs no chemicals, wastes no water, and being temperature controlled, it's also energy efficient. And at roughly 1,800 rupees per unit, it's low cost, scalable, and solar compatible option. Particularly suited for rooftops, rural ponds, and NGOs or refugee settlements. Yeah. Um, the future scope, looking ahead, the next steps are biological validation trials to directly measure larval density reduction, field deployment pilots with municipal bodies and NGOs, and adding solar assisted power with the IoT based remote temperature monitoring. To summarize, this is a simple, low cost, and chemical free mechanical system that activates precisely within the mosquito breeding temperature window, and it is ready for field scale validation. Thank you very much.
Thank you. Dr. Tiwari, do you have any questions?
Hello.
Yes, you're audible.
Yes, Kunal. I think Kunal. Am I pronouncing name is right?
Kabir, actually.
Kabir. Yeah, right. Sorry, Kabir. Very nice presentation, and your work is very good. Like you demonstrated your actual practical project. So, my question, it's a general question. Selecting the operating temperature threshold, which you have mentioned in the slides, right?
Sorry, I couldn't hear you properly.
Dr. Tiwari, could you please repeat?
Hello.
Yes, ma'am. Your voice was cracking, but could you please repeat the question? Okay, I believe ma'am might be facing some technical issues. In that case, we'll move on to the next presentation. Our next presenter for today is Smriti Dilip Dabhole, who will be presenting Confidence-Aware and MobileNet V2 approach for vegetable seed classification. You may now start.
Hello, am I audible?
Yes, you are.
Hi, this is Ashwat. I will be representing this paper. So, uh, good afternoon, panelists. My name is Ashwat, and this paper ID is 278. My paper is for confidence-aware and MobileNet V2 approach for vegetable seed classification. The authors are Dr. Smriti Dilip and Dr. Prashanta. As we go through the contents, this is my flow of paper. For the introduction of the problem statement, this manual seed verification, which is chemical, genetic, and visual, is slow and unscalable for field level agriculture for the vendors and farmers. Here we are facing issues with chemical and genetic seed testing and methods which require lab equipment and specialist supervision ruling out on the site users, especially in the farms or in the labs. Manual vision, manual visual and inspections is slow and doesn't scale to industrial seed volumes. Seed varieties are often visually near identical, making human or manual discrimination, which is very recognizable. The field conditions like lighting, orientation, and background are variability, and that causes manual and traditional methods that can't handle any normal models to use the various varieties or the various varieties of seeds. There is no existing automated solution for efficiently classifying seeds when varieties are visually indistinguishable, leaving a clear gap for a deployable CV-based systems. So, as I have gone through the literature survey, so we have uh, worked with some of the papers, and in their methods there are a lot of methods where we have used color histograms, GLCM textures, CNN based extractions, and deep learning models. The limitations were like fails under background lighting and orientation variation on the ground level, and non-agriculture specific, especially in the general purpose baseline. There are mostly problems between the class imbalance and dataset handling. Also, there are problems which limits ourselves for adding post-processing overhead and non-integrating with lighthead backbones. So, what we get from this challenges are high visually similarity among different vegetable seed varieties, which makes accurate classification difficult. And the class imbalance in the dataset leads to the biasness of learning of the model and poor recognition of minority classes. High computational complexity of conventional CNNs limits deployment on resource-constrained agriculture devices, especially for the vendors. And for the low confidence prediction, reduces the reliability of automated seed classification systems. So we got the objectives to develop a deep learning model capable of discriminating visually similar vegetable seed varieties with high accuracy, and it can help to the vendors and the farmers, which can improve classification performance on imbalanced datasets using focal loss and during model training. We designed a lightweight mobile net V2 based framework, which is suitable for the real time and edge device deployment, which can enhance prediction, reliability, and incorporating confidence aware filtering during inference. As for our contributions, we have proposed methodologies like we have to input, we have to give the input as our images, and the mobile net V2 framework can give the loss function for the particular image. And with the optimized method, we can get the confidence awareness, which will help the vendors or the users for getting the right output or the right proposed blocks of diagrams, where the architecture, the multi-class vegetable seed classification architecture, we are giving input images, which is 224 x 224, with the color filters of 32 numbers of filters, with the bottleneck inverted residual blocks, where we are reducing the image sizes into 3x16 dot 4x24. And with the 1280 filters, we are getting the global average pulling with the softmax output of 15 classes. We have used the publicly available dataset, which is the WedgeSeedDB, and from that particular data set, we have used 15 vegetable seed classes. As you can see on the right side, we have the table of varieties of pumpkin, pea, okra, bitter gourd, corn, papaya, and many more. We have 200 images of single seed, and for the bulk seeds, we have 100 images. With the 4,500 RGB images, we are getting 224 x 224 size pre-processing for the images. And for the experimental setup, we have the batch size as 32. And for the number of epochs, it's 40, because we got the optimal solution for this particular model in the 40 epochs. We have image size as 224, and the learning rate was 0.001. We have early stopping patients, which was 10. And for the result analysis, we have validation accuracy of 96.22%, and with the 98.1% high confidence prediction. As you can see on the right hand side, there is a confusion matrix. We can see that there is a very good amount of predictions, which is 98.1%. And then we have also reduced false positives by confidence filtering. This filtration process have helped us to reduce false positive numbers. And for this strong convergence and generalization, we have used the training model with 40 epochs only. As you can see, the graph, we can see the model accuracy over time of the training and the fine-tuning models. This is a really good marks, which include confusion matrix and training curves from the paper. As you can see, these are the results, where for the single image, a single seed, we are getting 100% confidence, and for the bulk as well, we are getting confidence of about 100%. For the comparative analysis, there are a lot of authors which have given other CNN models with 16 layers, and there are other papers which are densely connected with conventional networks with 90.4, 92.1, and many more. But for our proposed methodology or the proposed work, we are giving transfer learning plus focal loss, and with the addition of confidence aware filtering, we are getting 98.1 accuracy. This is the highest which we get. The conclusion for this paper is like we have made the lightweight and accurate model for all the vendors or the users for getting the right vegetable seed classification. With the suitable for edge devices, confidence aware predictions which improve trust to the end users. And for the future scope, we can use for the spectral imaging for maybe going with the organic or inorganic seed classification in the future with uncertainty learning. These are the shortlisted references which I have mentioned here. And thank you so much.
Dr. Tiwari, do you have any questions? All right. In case there's no questions, we move on to the next presentation. Thank you. Our next just a moment. Our next presenter is Ayush Ghorpade, who will be presenting Design and Development of Drone Docking Mechanism. You may now begin.
Hello everyone, am I audible?
Yes, you are.
Give me a moment, let me share the screen. Hello everyone, I'm Ayush and I'm here with my team today. I'll be presenting the paper on design and development of the drone docking mechanism. UAVs have currently become incredibly common. We see them everywhere, from infrastructure inspection to defense to agriculture to geological mapping. So all these operations need a autonomous deployment and docking system. But the problem is autonomous takeoff and landing. Persistent UAV missions need precise autonomous docking stations to completely eliminate the human intervention during the takeoff stage, the recovery stage, or the landing stage. So we do have return to home functions in current commercial UAVs, but there is a problem: the GPS accuracy. Standard GPS systems are highly effective for en route navigation, but they lack the centimeter level accuracy that we need for the precise docking. In the existing RTH function that we have in commercial drones, the GPS gives us coordinates. We use it for to go from point A to point B. But standard GPS modules do not actually work from point A to point B. They give us a data of region A and region B. So to go from point to point B, they take help of inertial measurement units, which measure the accelerations of the devices. So the device knows how it's moving, where it's moving. But these devices are also prone to drifts over a period of time. So by the time your mission is completed, the device might be drifted. So for docking purpose, we need centimeter level accuracy. We cannot rely on GPS. So our system, to achieve the centimeter level accuracy, it incorporates two primary sensors. One is the camera and another one is the time of flight sensor. The camera is for vision and the time of flight sensor will come to it. The camera will be used for visual guidance of the drone on the horizontal plane. It will not command the drone any information about the Z-axis. It will only be used for horizontal plane. So when our drone enters the FOV of the camera will scan the Arugo marker, which will be attached to the bottom of the drone. Now the dimensions and the pattern of this Arugo marker will be already known to the system because we will be designing the system. So during the deployment, our system will already be trained for the specific Arugo markers that we will use. So this will allow to estimate the drone's position along the horizontal plane at a distance above the dock. So using this camera, we'll get two pieces of data. One will be the X and Y values, which is the position of the drone above the dock, and the heading of the drone, which is nothing but the yaw angle of the drone. So the system will calculate these errors, and these errors will be given, these values will be given from the ground station to the flight controller on board the drone. Now the time of flight sensor. We have a camera, right? So why do we need time of flight sensor? Well, to estimate depth of an object, you cannot use a single camera. You will need either a depth camera or a stereo cam setting, but that will increase cost to very high values. So we use a time of flight sensor here. So while the camera will handle the X and Y alignment of the drone, the time of flight module will help it achieve a stable descent and touchdown on the docking station. So our time of flight sensor is mounted on a 2 degrees of freedom gimbal. So we have a pan axis and we also have a tilt axis or a pitch axis for the time of flight sensor. So it will operate in sweeps of a set degrees to scan the entire 3D space. Now, this time of flight module will give us actually measures three types of data. One is the physical distance between the sensor and the drone, the azimuth angle using the pan servo, and the elevation angle using the tilt servo. So we get three data here: the measured distance from the sensor, the azimuth angle, horizontal plane, and the elevation angle. With that, we can get the spherical coordinates for the system. But the flight controllers of the drone do not work with spherical coordinates. They need the data in X, Y, and Z. To make this data usable, we'll convert the spherical coordinates to Cartesian coordinates using these equations. Now you can see in the diagram here, we have the projection of the drone on the dock, and the values such as R, X, Y, and the dimensions of the entire docking platform are known to us while designing the system. The azimuth angle and elevation angle will be given by the servo motors. So with that, we can find out X, Y, and Z coordinates of the drone's position in the 3D space. And once we have the drone's instantaneous position, we can use those coordinates and the coordinates where we want our drone after it lands by using the distance formula. In our design, we have assumed the time of flight sensor to be the origin of the system. We can also keep the camera as the origin of the system, but in our system, we have kept the time of flight sensor as the origin and camera as the docking center. This is the summary of the complete procedure. The drone enters the field of view of the camera. The camera will scan the Aruko marker attached to the bottom of the drone. That will help us identify the drone's position. It will give us X and Y values of the drone over the dock and also its heading, the yaw angle. So now the system will compare these values to the docking station center, which is 0, 0, and we need 0 degrees. So with that, it will send negative values to the flight controller such that it aligns the drone, and then the drone after it is aligned over the docking station, the gimbal sweep will start. Once the gimbal locks into the drone, once it detects the drone, it will record the position into spherical coordinates. And as we saw, the spherical coordinates will be converted to Cartesian coordinates, the X, Y, and Z values, so that the flight control can process. So after processing the distance data, the ground station will send the command to the drone controller and it will start the descent. Now again here there's a problem. As height increases, the resolution of the camera suffers. So it's not necessarily that the drone will come down in a straight line. It might come down in steps. So for that, the entire process will repeat after each set value of the descent. And once the landing is complete, we dock the drones in. Here are the some shots from the experiments that we conducted. Here's the Aruko marker that we were using for the alignment of the drone in the horizontal plane. Here is the time of flight setup. We were using 2 degree of freedom gimbal. This is the drone from another project we were developing. We used the same drone for this project and attached the Aruko marker to its bottom. These are the values from the TF sensor. We get three types of values. One is the distance, azimuth angle, elevation angle. This is the sample data for the post correction, how it looks like. For example, the drone is 20 centimeters offset along the x-axis. So it will send the commands for minus 20 dB. Again, please note that the ground station does not control the drone. The ground station only sends the set point commands to the flight controller of the drone. The decision to whether to land or abort it is by the flight controller. And these are the dimensions of the docking station. We try to keep it under 300 millimeters of a square. So with this, we complete our project. Thank you, everyone. If you have any questions, you are welcome.
Hello. Dr. Tiwari is facing some technical errors, but should she write any questions in chat, I'll relay those back to him. Dr. Tiwari, do you have any questions? All right, we'll move on to the next presentation. Our next presentation for today is by Kashika Bharadwaj, who will be presenting Fake News Detection System using Machine Learning. You may now begin your presentation.
Okay. Good afternoon, everyone. Am I audible?
Yes, you are.
Okay, ma'am. Okay, good afternoon, everyone. I'm Kashika Bharadwaj, and today I'm presenting my research paper, Fake News Detection System using Machine Learning. And it is a comparative study of logistic regression, support vector machine, random forest, and XGBoot for classifying real and fake news. So this presentation is divided into 6 sections. So the introduction part. Fake news has become one of the biggest challenges in today's digital world. Millions of news articles are shared every day through social media platforms such as Facebook, X, Instagram, and online news websites. So, because misinformation spreads almost instantly, false information can reach thousands of people because it is verified. And fake news can influence public opinions, affect elections, create panic during emergencies, and spread misinformation related to health and finance. So, the objective of a research paper was to develop a machine learning model capable for classifying news articles as either real or fake, using textual and linguistic features. So for this research, we used a dataset containing 853 news articles, out of which 569 were real news articles and 284 were fake news articles. So coming on the methodology, our methodology follows the KDD process, which is a standard framework for data mining and machine learning projects. The first step was collecting the dataset consisting of real and fake news articles. Since the machine learning model cannot directly understand text, so we convert the textual data into the numerical features. For this purpose, we use TF-IDF, which stands from Term Frequency Inverse Document Frequency. And TF-IDF assigns higher importance to the words that occur frequently within a document, but are relatively uncommon across the entire dataset. So this helps us identify the most informative words while reducing the influence of very common words. Along with this TF-IDF, we also incorporated linguistic features that provide additional information about the writing style and structure of the news article. Next, we trained four different machine learning models. First, logistic regression, which is simple yet powerful linear classifier. Then, second is the support vector machine, which finds the optimal boundary between different classes. Third is the random forest, which is an assemble learning algorithm based on multiple decision trees. Finally, the XGBoost, an advanced gradient boosting algorithm that is widely known for a strong predictive performance. To compare these models fairly, we evaluate them using the three standard matrices, which is accuracy, F1 score, and ROC. These are the results. The table summarizes the performance of all the four machine learning models. As we can observe that logistic regression achieves the best overall performance with an accuracy of 92.33%, F1 score of 92.32%, and ROC score of 97.83%. XGBoost also achieves 91.63% accuracy, followed by SVM with 90.37 and Random Forest obtained by 87.75. Although XGBoost is generally considered a highly powerful algorithm, it did not outperform logistic regression in our study. This is because our data set was relatively small and represented was using TF-IDF features. So linear models like logistic regressions are naturally well suited for this type of high dimensional text data and therefore generalize better than the more complex tree-based ensemble models. The result demonstrates that selecting the right model depends on the characteristics of the dataset rather than simply choosing the most complex algorithm. Next, coming on the confusion matrices. This slide presents the confusion matrix of all the four models. A confusion matrix allows us to see how many news articles were classified correctly and where the models made mistakes. One important observation is that fake news articles were comparatively harder to classify because they represent the minority class in a dataset. And among all the four models, logistic regression produces the most balanced prediction with the fewer overall misclassifications. So the XGBoost and the SVM also performed well and productive competitive results. Random Forest showed the highest number of classification errors among the four models. This analysis helps us understand not only the overall accuracy but also the type of mistakes made by each classifier. Next, coming on the ROC curve, this slide shows us the ROC analysis. which illustrates the relationship between the true false rate and the false positive rate at different classification thresholds. The area under this curve, known as the AUC, indicates how effectively a model distinguishes between real and fake news. So, our logistic regression model achieves the highest accuracy of 97.83%, which is the AUC, and the remaining models also achieve the high AUC scores, demonstrating strong classification performances. So, this is the model implementations. Based on obtaining the higher accuracy, it is also important to understand why the model makes certain predictions. So therefore, we analyzes features importance using random forest and XGBoost. This analysis revealed the text length, word count, sentiment related features contributed significantly to distinguish between real and fake news. So this improves our system because we can identify which textual characteristic influences the model's decision. And next, coming on the visualizing class separability. Uh, to better understand this feature, we apply two-dimensional reduction techniques, PCA and TSNE. These techniques transform high-dimensional TF-IDF features into two dimensions for visualizations. Although some overlap exists, both visualization clearly shows meaningful separations between real and fake news articles. So this indicates that our extracted features successfully capture useful information for distinguishing between the two classes. These visualizations also support the strong classification performance and achieved by strong classification performances which are achieved by our machine learning models. Next, coming on the conclusion, our study compares four popular machine learning algorithms for fake news detection. Among them, logistic regressions achieve the best accuracy, which is 92.33%. Our result demonstrated the combining TF-IDF with linguistic features, providing an effective and conceptually effective approach for fake news classifications. For future works, we plan to evaluate this proposed framework on larger and more and more bigger data set, which will improve the detection of minority class fake news and explore advanced deep learning models such as BERT and transform based architectures. These are some of the key references I have taken, uh, which are included in a research paper. Thank you so much, and this brings me to the end of my presentation. Thank you for your valuable time and attention. I'm happy to answer your questions.
Hi, Kashika. Dr. Tiwari has written some questions in chat, so I'll just ask you those. Which features contributed most significantly to improve detection accuracy?
Okay, ma'am. Just a minute. Which feature one? Which feature contributes to the most significantly to improve detection accuracy? And ma'am, the second question also, how can such systems avoid bias while classifying news contents? Okay, ma'am. So, ma'am, based on the features contribution, which is analyzed using random forest and XGBoost like text length and word count, our sentimental related features contributed more towards improving detection accuracy. Among these, the TF-IDF features were the most important because they capture the significance of informative words in the news articles. So these features help the most distinguished between the real and fake news effectively. And ma'am, the second question which ma'am asked me, which was how can such systems avoid bias while classifying news? So, ma'am, bias can be reduced by using a balanced and diverse data sets. That includes news from the different sources, topics, and viewpoints. During pre-processing, we should remove noisy or irrelevant features that may introduce bias. It is also important to evaluate the model using multiple matrices like precision, recall, F1 score, AUC, ROC, instead of relying only on the accuracy. So, finally, regular updated data and testing on unseen data sets helps ensure the model remaining fair.
All right. Thank you, Kashika.
Thank you so much, ma'am.
We will now move on to the next presentation. Our next presenter for today is Palash Thakkar, who will be presenting Guard LLM, automated security testing for large language models in production environments. Palash, you may now begin.
Hello, am I audible, ma'am?
Yes, you are.
Yeah. Good afternoon, everyone. I am Palash Thakkar, and today I will be presenting our research work titled Guard LLM Automated Security Testing for Large Language Models in Production Environment. This research was carried out by me along with my teammates Harsh, Rudra, and under the guidance of Rupali ma'am, Nilakshi ma'am, and Archana ma'am at the Department of Cybersecurity Engineering, Shah and Anchor, Kutchi Engineering College. In today's presentation, I will be briefly explain the motivation behind Guard LLM, its architecture, security evaluation methodology, experimental result, and the key contribution of our work. So why Guard LLM? So large language models have become an essential part of modern application, such as customer support, banking, healthcare, education, and enterprise system. However, despite their powerful capabilities, they are vulnerable to several security threats, including prompt injection, data leakage, jailbreaking, hallucinations, and context manipulation. Exciting LLM security testing tools often require command line expertise, are difficult to configure, or depend entirely on cloud services, which may expose confidential prompts and sensitive organizational data. To overcome this limitation, we developed Guard LLM, a browser-based framework that automates LLM security testing while supporting both cloud-based and privacy-preserving local execution. So, proposed solution. So, Guard LLM automates the complete security testing workflow for large language models. It supports two execution models. First is cloud model using Google Gemini APIs and local model using Olama hosted language models such as Llama 3.1, Gema, and Tiny Llama. The framework automatically generates adversarial attacks prompts, evaluates the model response during during response using heuristic analysis, and produce interactive dashboard along with comprehensive PDF security reports. This provides an essential to use, scalable, and privacy preserving solution for evaluating LLM security. So, what is system architecture? System architecture is this like slide illustrate the overall architecture of Guard LLM. The workflow begins with the user selecting the target language models and preferred execution mode through the browser interface. The front end is developed by using React and TypeScript. Within the backend is implemented using Flask. If the user selects uh, re- cloud mode, its requests are securely sent to Google Gemini API. Alternatively, if local model is selected, its requests are proceeds using locally hosted Olama models without sending sensitive information over the internet. Once the model generates a response, our heuristic analysis engine evaluates it against different attack scenario to determine whether the response is secure or vulnerable. Finally, the results are displayed on the interactive dashboard and a detailed PDF security report is automatically generated. This modular architecture enables both flexible deployment and privacy-preserving security assessment. Threat matrix. Threat matrix to ensure comprehensive security testing. Guard LLM evaluates large language models using 20 points of threat matrix. Like the first category is consist of OAuth's LLM top 10 attacks. Its risks including prompt injection, data leakage, denial of service, model theft, insecure plugins, excessive agency, and data poisoning. The second category was focused on advanced adversarial attacks such as cross-lingual attack, payload obfuscation, context execution, persona adoption, few shot jailbreaking, tokens suffixing. These are the together these attacks are scenario provides a realistic and comprehensive assessment of the modern language model security. Second is evaluation pipelines. The evaluation process consists of 5 stages. First stage is the target model and the testing configurations are selected. Next is Guard LLM automatically generates adversarial attacks prompts. The response are collected from the selected language models and analyzed using our heuristic evaluation engine. Each response is classified into 1 or 4 categories. First is pass, warning, fail, or error. Finally, the framework generates an interactive dashboard along with the downloaded PDF security reports, allowing users to easily understand the security postures of the evaluated models. These are the experimental result. So to validate our framework, we evaluated 4 languages models, that is Google Gemini, Flash, Meta, Google Gemini, Gamma, and Tiny Llama. The So the table presents the vulnerability percentage of tier 1 OAuth attacks and a tier 2 advanced adversarial attacks. So lower percentage indicates stronger resistance against attack. Among the evaluated models, Gemini 1.5 Flash demonstrate the strongest security performance, while the Tiny Llama 1B shows the significantly higher vulnerability, particularly against the advanced attack scenario. These results demonstrate the Guard LLM effectively identify vulnerabilities across both cloud-based and locally deployed language models. So these are comparisons. We compare Guard LLM with the existing LLM security testing framework. Unlike many existing solutions, Guard LLM is browser-based, required zero configuration, supports both cloud and local execution, provides a broader WAPS LLM coverage, and automatically generates detailed security reports. This capability makes Guard LLM more practical and accessible and suitable for both research and developers. This result and contribution. So the major contribution of our work is include a browser-based LLM security testing platform, which dual model cloud and local execution. Third is automated adversarial attack generates the comprehensive 20 points threat matrix. The automated PDF security reporting, privacy preserving local execution. Overall, Guard LLM provides a practical, cost-effective, and production-ready solution for evaluating the security and large language models. So, conclusion. So, we developed Guard LLM, a browser-based framework for automated LLMs for security testing. The framework supports both cloud and local execution, evaluates language model using 20 OAuths and advanced adversarial attack scenario, automatically analyze model response and generates comprehensive PDF security reports. Our experimental evaluation is demonstrated the Guard LLM can effectively identify vulnerabilities while providing a scalable, privacy preserving, and user friendly solution for securing large language models. Thank you for your attention. Any questions?
Hi, Palash. Dr. Tabari has put down a question in chat. How does Guard LLM differ from existing AI security testing approaches?
One second, ma'am. Guard LLM differs by bridging the gap between research-heavy command line tools and privacy-violating commercial platform, offering a zero configuration browser-based interface that perform deep security testing locally without exposing sensitive data. Its unique dual model architecture and 20 points threat matrix provide professional grade auditing with the absolute privacy of an offline terminal tools.
All right. Any other questions, ma'am? Okay. In that case, we move on to the next presentation. Thank you, Palash. Our next presenter for today is Arnav Joshi, who will be presenting Intelligent Multimodal Eye Blink-based Home Automation System for ALS, Quadriplegic, and Stroke Patient. You may now begin.
Hey, good afternoon, everyone. I hope I'm audible.
Yes, you are.
Yeah, let me share my screen. I hope my screen is visible.
Yes, it is.
Okay. So, good afternoon, everyone. I will be presenting about my paper, which is titled as iBlink and iGaze based smart environment control system with facial authentication. So my teammates were Soham, Janvi, Arnav, and Roshni, and we were guided by Dr. Priya Surana. So on behalf of them, I will begin the presentation. So talking about the problem statement, iBlink and iGaze based smart environment control system with facial authentication. So our project focused on developing an assistive smart home system that enabled individuals with motor disabilities like ALS, paralysis, quadriplegia to control household appliances in their environment using eye blink and eye gaze movements. Through this, we aim to eliminate the need of physical movements or speech, which is a problem with such individuals. Hence, like the motto of our project was to restore independence, improve safety, and enhance the quality of life for such affected people with mobility limitations. So moving on to the literature review, I'll give you a brief about the top 8 papers we referred for our research, starting with neurobiometric and iBlink-based biometric authentication system using event-based neuromorphic vision sensor. So, talking about this paper used custom blink detection algorithm via MATLAB, which also had like neuromorphic vision sensor enabled with a Davis camera and a microcontroller. The highlight of this paper was that it achieved high authentication accuracy up to 90% with low latency. The only gap that we found in this research was scalability. Like whenever we aim to uh, enlarge the base of this project, it could uh, cause possible attacks, and like they needed improvement in environments where dynamic lighting was involved. So that was the research gap that we found out. Next, moving on to the RT blink, a method toward real-time blink detection using single frontal EEG signal. So this paper proposed a random forest-based real-time blink detection channel EEG for BCI applications, enabling accurate identification of eye blinks using granular windowing and ML features. So this paper included random forest classifier, MATLAB code, and the highlight of this was they used EEG headset, which is a single frontal channel, and they achieved around 96.54% precision, 91.25% average processing time, and average processing time of 5.07 milliseconds per window. So only the gap that we identified with this paper, was that it needed further parallelism improvement scalability with other signals and broader real-world usability. Coming next to the next papers, automated smart home assistive system implementation for physically impaired community using eye gestures presents a home automation system using webcam-based eye tracking where eye gestures were detected via OpenCV and MediaPipe, which are Python libraries, enabling hands-free control for physically impaired users. So here, the highlight was that they incorporated OpenCV, MediaPipe, machine learning algorithms via AutoGUI, and the hardware that they used was Arduino IDE. So this was a nice robust hands-free appliance control that they offered using eye gestures, and it also provided good detection accuracy. The only demerit of the paper was that they needed to improve the robustness due to varying lighting that could possibly cause problems. Coming to the next paper, gaze tracking control system for wheelchair and automation, smart home automation. This paper concentrated on controlling both wheelchair mobility and smart home devices using gaze tracking. This also, like the previous paper, included OpenCV, MediaPipe, NumPy, and Arduino microcontroller. So this was also a successful prototype, which was also unique because they tried to uh, incorporate wheelchair mobility as well. The only problem with this was optimization in terms of real-time performance in diverse environments. Going next, the fifth one that we studied was real-time eye blink recognition for virtual mouse using Raspberry Pi. So they developed a low-cost real-time eye blink recognition using Raspberry Pi to control a virtual mouse that they could use to access applications, emphasizing affordability and accessibility, which was a high point of this paper. They did this using computer vision algorithms and leveraging facial landmark detection. So they achieved around 70 to 80% accuracy. Also, one highlight was that it was a low cost implementation, which incurred low cost as well as low power consumption for continuous operation. One of the gap with this one was like similar papers, varied lighting and varied movements were not captured that much with that much accuracy. Moving on to the next paper, smart home automation, a simple system for controlling home appliances and alerting caregivers using blink counting IR sensor. So here, what was different from the rest of papers was that they used an IR sensor combined with Arduino IDE and ESP32 microcontrollers. So the functional prototype controlling 4 appliances and 2 voice alert messages was their prototype, which was a good one. Like it was a unique identification in this field. But the research gap with this one was it was highly susceptible to false triggers from ambient IR interference, and it offered a very limited command set. So that was the demerit about that research paper. Moving forward, the seventh one was eye tracking based wheelchair control and SOS system, another one with the wheelchair ability. So in this, there was eye tracking wheelchair system using Raspberry Pi that detected blinks and eye movement control, wheelchair motion via SOS alerts via IFTTT, offering low cost mobility and support. So the highlight was that they achieved around 82% accuracy for eye movement blink detection, effective real-time control under good lighting. The only gap was like low accuracy in low light or varied light environments and lack of obstacle detection. Moving on to the last paper that we studied was embedded systems for eye blink detection using machine learning techniques. So that proposed an efficient low-cost embedded system for eye blink detection using EAR, that is eye aspect ratio algorithm, combined with Raspberry Pi platform and OpenCV libraries. So the highlight of this paper was they achieved around 2 to 3 frames per second processing rate and accurate calculation due to EAR. But the performance limited by processing speed needed some optimization considering real-time applications. So that was one of the demerit about this paper. So talking about the current solution in critical gaps, like voice control systems exist, but the limitation is like ALS patients tend to lose their speech also. That condition is known as dysarthria. So that is why we should consider something that uh, does not have voice related to it. So hence we considered I based implementation. Then switch systems, like the physical buttons used needs motor function, so that one also cannot be used. Commercial eye trackers also exist like Tobii Dynavox, but they cost around $3,000 to $15,000 per person, and they are single user based and they do not provide any authentication. Similar gaps with the brain computer interface, for example, Neuralink.
Hello, I'm so sorry to interrupt. Excuse me. You have less than a minute left.
Okay, sure. So I'll skip these slides. I'll talk about our implementation. So what we implemented was real-time facial tracking, media pipe face mesh that tracks around 468 3D facial landmarks at 30 frames per second, even on low-cost hardware. Uh, coming next, the system works reliably within 0.5 to 1.5 meter range and activates only when the face is detected, improving efficiency and reducing fault triggers. So we tried to work upon the gaps that we found out. I'll quickly walk you through the high points of our implementation. So our innovation layer consisted of integrated face authentication, adaptive eye tracking for spectacles, like the users having spectacles, and multiple device control as well. Yeah, that's it from my side. Thank you for your valuable time. I'd like to answer any questions if anyone has.
Hi, Erna. The questions in chat are, what measures have been considered to improve user comfort during long-term usage?
Yeah. So most of the implementations did offer a wearable device or something that has to be attached to the human body. But in our implementation, we considered that in terms of long-term usage, a wearable device can cause discomfort to such peoples. Hence, what our aim was that we should not have a wearable device. We should consider the user's comfort as our first priority, and hence we do not have any wearable device or something that has to be attached to the user's body. The camera and all the setup is just fixed at some optimal distance, and like the user can uh, behave with the environment casually. So that was one of the measures that we considered. And answering the second question, like how can this technology be integrated? So yeah, what our system implements is that the camera is set up at an optimal distance around 30 to 35 centimeters away, and like the raspberry and all the components are at a distance as well, and the user can operate, like we had kept a multiple device operation, so the user could operate up to 5 devices, which also included like an emergency buzzer alert. So in case of an emergency, when the user blinks rapidly, that alert would give a buzzer, and a caregiver could respond. So that's how we integrated this technology.
All right. Thank you so much. We'll now move on to the next presentation. Our next presenter for today is Tushar N, who will be presenting IoT-based soil monitoring and machine learning-based crop recommendation system. You may now begin. Is Tushar or any of his co-authors present? All right. In that case, we'll move on to the next presentation. Our next presenter for today is Arya Bhutte, who will be presenting Meeting Transcript Summarization using Fine-Tuned BART, a query-focused approach on the QM-SUM dataset. You may now begin. Is Arya or any of his co-authors present? All right, that brings us to the next presenter for today. Next up, we have, next up we have Gagan. Thank you. All right. Next up, we have Gagandeep Singh, who will be presenting Review on the Effects of AI on School Children's Sustainable Education, Systematic Learning, and Career Development. You may now begin.
Hi, good evening, everyone. Hi, once again, good evening, everyone. So basically, my topic is it's a systematic review on the effect of AI on school children's sustainable education, systematic learning, and career development. So basically, in this, what I have done is I have studied a number of papers starting from year 2018 to 2026, and on the basis of the number of research which has been conducted by different researchers. So I have taken their outputs and accumulated in this one literature review paper which I have published. So the evidences which has been collected for the review of this literature is from the year 2018 to 2025. And it is basically based on the adaptive learning, formative assessment, generative AI, and AI-driven careers. So what are the different options which we have? So basically, as we know that AI has become um, a main integral part of our education system, where the schools are implementing the use of AI technology in their classroom. Some of the schools they are not using it because still there is a lack of defined guidelines which is required by the schools, or maybe a school can prepare their own guidelines which are required further to be transferred to the teachers. Up to what extent these technologies are needed to be integrated into the education system? So there is something which different organizations and different education bodies and boards they are working on it. So in my case, it's just a beginning. So as a beginner, I've just done a little bit of a review of up to what extent this has been taken forward, what are the limitations, and how those limitations can be taken care of. So it's just a small introduction. So as we know that AI education is basically SDG Goal 4, which is talking about the equality and sustainable education for each and everyone by 2030, that every child should have a proper education and it should not be biased in terms of that they should not be segregated in any factors. So everyone should have fair and equal education. So basically, AI is reshaping how school children learn, as I said, and plan careers, promising personalization and efficiency, but spreading faster than policy and governance can keep pace. So there are three key points. Examine how AI influences sustainable education, systematic learning, and career development. Synthesize interdisciplinary evidences into evidence-based policy and practice recommendations. Apply a validated technology organization environment framework tested via PLSM SCM 239 respondents. So basically, these are taken from the research work which has been already done by the other researchers. So what I have done is it's divided into this one. So basically, first I defined the objective, that how much or up to what extent I want to take myself. Then number of research papers has been downloaded, thoroughly studied, taking out the key points which are relevant to my work. So for that, I have done literature search. Study and screening to take out their abstract reviews. Eligibility check if it is relevant to me because I have set a criteria of having all the documents from 2018 to 2025. So that was the time period which I picked for my research work. And then further data extraction, the data has been extracted, which is required by me, and then thematic it synthesizes. AI for sustainable education, there are some of the organizations which are definitely working on this, starting with the UNESCO. So AI can transform how we teach and learn. OECD, AI can widen inclusion gap where digital infrastructure inclusive designs are not prioritized. NET assessment, AI is framed consistently as both an opportunity and a risk for long-term equitable education. When it comes to the performance in terms of adaptive, performance in terms of engagement, performance in terms of grading time reduction, performance in terms of career readiness. So basically, if we see, definitely AI has surpassed the traditional method which was used to be followed. Like if we talk about career readiness, then in career readiness, we can see there is a huge gap of improvement is there. And yeah, definitely, if we look into this career counselings and other systems which different career organizations they are following. So basically, what they are doing is they are also taking a psychometric test of a child. They are doing some of the automated assessments, and on the basis of the outcome of those assessments and other testings, they used to propose a child that okay, this particular career path is going to be good for you, and this are the options which are available for you. So definitely in either or the other way, they are using the AI tools in making a particular decisions. Grading time reductions, evaluation of the answer sheets is being um has like the time is reduced and the process has become much quicker. Engagement and adaptive learning. So from the point of what I have learned from the student point of view also is that AI supports them in learning a particular topic which they are not able to grab in a class when they are in a traditional classroom approach. So they, whenever they are in such situation where they don't find it yeah, every teacher has their own way of teaching, and students have their own pace of learning also. So there are some AI tools which are more interactive and gives a more fun environment for them to learn, which they miss sometimes in traditional classroom approaches. So that make their learning process a bit faster, or it completes their learning cycle, what we can say in other words. So where there we have seen that a huge increase is there. So when that's the same thing which I've already explained, AI and career development from psychometrics to personalized guidance. So we have early exposures, wider awareness of in-demand career and skill pathways among school children, aptitude alignment recommendation grounded in individual behavior and preferences data. So these are the information which are given by them, and we generate an report. Rural research, mobile ML recommenders, extend vocational awareness beyond urban centers, human mentorship, most effective when paired with counselors to contextualize AI suggestions. So definitely AI has some of the good things that they speed up the process. They give a fun learning environment for a child to learn. Different tools and platforms are available nowadays. Assessment has become very fast. So, but on the other side, like each coin has two sides. So one side is there, the other one is risk and challenges are also, which are as a limitation in the application of these tools in a classroom. So the first and the foremost is the digital inequality. There's a gap in connectivity, devices, and skill leave disadvantaged student further behind. So definitely the one who are more strong in terms of finances, they have more access to the resources and the technology as compared to the other part of the society which are lacking behind. So somehow there is a digital gap which is still there. Algorithmic bias Incomplete data can misdirect career advice and misjudge at risk learners. So we are not 100% dependent on this. These tests are not 100%. Data privacy, yes, one of the major other concern is child data protection, surveillance, and unclear decision making remain unresolved. Teacher readiness, many teachers feel unprepared, limiting pedagogical sounds AI use. So yes, most of the schools they have taken this as a new tool, but we have to keep this in mind that the teachers who are teaching in traditional classrooms from last 25, 30 years, so they also need some sort of training and they need proper guidance so that they can be upgraded also. Over resilience, unscaffolded, use weakness, independent thinking, and problem solving, fast changing job needs. Skills taught may lack what a fast evolving job market requires. Uh, Further weighting the trade off. So, AI has some of the benefits and some of the drawbacks as compared to the job market readiness. So, when it comes to the good things, it's a personalized, flexible learning that closes gap, wider access via tutoring and translation where teachers are scarce, strengthen 21st century skill, critical thinking, computations, automated
Excuse me.
assessment.
I'm so sorry to interrupt. You have 1 minute left.
Yeah, automated assessment frees teachers' times for mentoring, build lifelong self-directed learning habits, familiarize students with tools used across further industries. And on the other side, there are some of the disadvantages. And the disadvantages are widened inequality for students, risk of over dependence, privacy, surveillance, data misuse, because we are inputting as many data as we can to get the answers. Biased career algorithms, uneven teacher preparedness, output can be inaccurate, incomplete, or misleading. And when it comes to the policy and practice priorities, infrastructure and access, so universal connectivity and device programs target to understand underserved, communities, teacher professional development, which should be there from time to time, so that the teachers can be should be kept up to date from the changes in the technology which are coming. Ethics and data governance, child data protection, transparency. So although if we are using any psychometric test or any other form of assessment for the assessment of a child. But the other side of the story is that we have to keep those data confidential because these data are related to a minor. So minors' data should not be taken out without the consent of their legal guardians. And human in loop design, mandatory human oversight for high stake tracking, counseling, and recommendations. So, and last is just a conclusion. So basically, we need to fund sustained teacher professional development, which is one of the most important thing, enact ethical governance and data protection so that we can preserve the data and preserve human oversight in high stakes decision. So this is all from my side. Thank you so much for listening me.
Thank you. There's a question from the chair in the chat. What research gaps did you identify regarding AI adoption in sustainable education?
Basically, when we talk about sustainable education, yeah, AI is basically the main concern or the main gap which I have seen is the adaptation of the AI in schools. Because the technology is there and the schools are opting for students, they are having free access to the internet, they are definitely more smart, but no one has prepared a proper guidelines that up to what extent these technologies has to be integrated into a class. Like for example, if you have given an assignment to a child for writing an essay, so let him use the AI technology to get a different ideas and other things, but up to what extent that there should be a full stop that the whole essay should not be written by an AI. But yeah, a support taken by AI, it can be there because this is something which you cannot eliminate or which you cannot remove from this thing. So that's where I found a gap. Yes, please.
All right, thank you. Just one moment. All right. So we'll just circle back and check if any of the absentees are now present in the meeting. So I'll be calling out their papers again, just a moment. So if Tushar M or any of his co-authors are present in the meeting, please let me know. All right. Next, if Arya Bhoite or any of his co-authors are present in the meeting.
Yes, ma'am. Can you hear me?
All right. Okay. So now we'll be seeing meeting transcript summarization using fine-tuned BART, a query-focused approach on the QM sum dataset. You may now begin.
Yes, ma'am. Let me share my screen. Good afternoon, everyone. I'm Kaustubh Dhumal, and along with my teammates Arya, Chaitanya, Pushkar, I am representing our project titled AI Meeting Summarizer under the guidance of Nikhilesh Mankar sir. So basically, our project focuses on automatically generating query-based summary from meeting transcript using AI and NLP. So introduction. So nowadays meetings are conducted every day in companies, colleges, and online platform. Reading an entire transcript after every meeting is time consuming. So meeting transcript. So this meeting transcript summarization converts long conversation into short and meaningful summaries. It helps users quickly understand the discussion, decision taken, and action items. So basically the existing system generally creates one generic summary for everyone, but the user often need answer to a specific questions. So this is our that is the gap of our project addresses. Project objective. The main objective of our project are generate summary based on user queries instead of only general summaries, improve accuracy using fine-tuned BART model, handle long meeting transcript efficiently. Problem statement. Existing meeting summarization system generates only general summaries. If a user asks what decision were taken or what did the manager say about the budget, traditional system cannot answer accurately. Therefore, our project focuses on query-based summarization, which provides summaries according to the user's questions, making them more relevant and useful. This is the taxonomy chart. This chart represents different types of text summarization techniques. Summarization can be extractive and abstractive. Our project belongs to abstractive query-based summarization, where the model generates new sentences while considering the user's query. So we study the literature review. We study several recent research paper related to meeting summarization. One paper proposed an LLM-powered meeting recap system. Another introduced an efficient framework for handling long meeting transcript. We also study a new evaluation metrics for measuring summary quality. This study helps us identify limitation in current system and inspire our approaches. Methodology. Our project follows seven major steps. First, we collect meeting transcript from the QM-SUM dataset. Second, we pre-process the data by removing unnecessary symbols and formatting the text. Third, we combine the user's query with the meeting transcript. Fourth, we can find the BART model using the prepared dataset. Fifth, the model is trained and validated. Sixth is the trained model generates a query-based summary, and finally we evaluate the generated summaries using row score. The model used. The project consists of 5 models: the data pre-processing model, clean the transcript. The query processing model process the user question. The the model training module fine tune the BART model. The summarization module generates the final summary. Finally, the evaluation module measures the quality of the row score. This is system architecture. The workflow starts with the meeting transcript and the user's query. Both are passed into pre-processing stage. The pre-processed input is then given to the fine-tuned BART model. The model generates the query-based summary. Finally, the summary is evaluated and shown to the users. These are the results, and this is the of our projects. The challenges during the development, we face several challenges. Speech recognition accuracy decreases because of background noises and overlapping speakers. Long meeting are difficult because transformer models have length limitation. We also consider privacy issues by handling meeting data. Finally, the market already contains strong competitors such as Otter.ai, Microsoft Copilot, and Google Meet. So creating a unique solution was another challenge. To conclude, we successfully developed an AI-powered meeting summarization. Uh, it generally uh, it generates query focused on summary instead of only generic summaries. Our system improves productivity, reduce manual efforts, and extract important decision and action items. In the future, the system can be enhanced with multi-link speech recognition, integration, and real-time meeting summarization. These are the references. Thank you.
Thank you, Costa. There's a question from Dr. Tiwari. Why was BART selected for this task compared with other transformer-based models?
So basically, we use BART because it generates summaries. It generates summaries according to the user's question instead of summarizing the whole meeting. For example, let's what were the final decision. So the model returns only the decision related to the content.
All right. Thank you so much.
Mm.
With that, we come to the end of our session. I sincerely thank all of our authors for their excellent presentations and contributions in this session, and all our participants for being a part of this international conference. I hope this session was informative, and on behalf of the whole team, I thank you for your support during this 11th version and all the previous 10 versions of the conference. We will be happy to have you in the 12th version in 2027. All the presenters will be receiving their digital certificates via email within the next 2 working days. The publication will be live in 7 to 8 months. Kindly cooperate with the team of ICT4SD 2026. I would also like to thank our session chair, Dr. Nidhi Tiwari, for chairing the session. A token of appreciation to the chair on behalf of Team ICT4SD 2026 and Global Knowledge Research Foundation and partners. Thank you so much for your valuable presence. Before we end the session, I would like to request everyone to please switch on their cameras for a quick virtual snapshot. All right. Thank you so much, everyone. That's it for today. The session is adjourned.